Pointers are one of the most powerful and fundamental concepts in the C programming language. A pointer is a special type of variable that stores the memory address of another variable rather than storing a direct value. This ability to access and manipulate memory directly makes pointers an essential part of systems programming, embedded development, operating system design, and many advanced algorithms. Although beginners often find pointers difficult to understand at first, their importance and usefulness make them a critical topic in any C programming course. In a typical program, variables store values such as integers, characters, or floating point numbers. However, each of these variables also occupies a specific location in the computer's memory. A pointer stores this memory location, allowing programs to refer indirectly to a value. To declare a pointer, the asterisk symbol is used. For example, int p declares a pointer named p that can store the address of an integer. To assign the address of a variable to a pointer, the address of operator and is used. For instance, if we have int or equals 10, writing p equals and r stores the location of r in the pointer p. The dereference operator is used to access the value stored at that address. So p gives the value of a. Pointers provide a wide range of capabilities. One of the most common uses is in functions. C supports call by value by default, meaning functions receive copies of variables rather than the original values, by passing a pointer to a function. The function can directly modify the original variable. This technique is essential when writing functions that must update multiple values at once, such as swapping two numbers or returning multiple results from a single function. Pointers are also closely associated with arrays. In C, the name of an array acts like a pointer to its first element. This means array elements can be accessed through pointer arithmetic, such as incrementing a pointer to move through memory sequentially. Dynamic memory allocation is another major application of pointers. Using functions like malloc, calloc, and realloc, C programs can request memory from the heap at runtime. These functions return pointers to the allocated memory. Without pointers, dynamic memory allocation would be impossible. This feature allows programs to create data structures of variable sizes, such as linked lists, trees, stacks, and queues. These structures rely heavily on pointers to connect nodes and manage memory efficiently. Although pointers are extremely useful, they must be handled with care. Improper use of pointers can lead to serious issues, such as segmentation faults, memory leaks, and undefined behavior. Common pointer errors include dereferencing null or uninitialized pointers, accessing memory that has already been freed, and performing incorrect pointer arithmetic. These errors can cause programs to crash or behave unpredictably. Therefore, programmers must ensure that pointers are always assigned valid addresses and that memory allocated dynamically is released using the free function. Despite their complexity, pointers remain one of the most important features of C because they offer flexibility, efficiency, and control over memory. They enable advanced programming techniques and allow developers to interact closely with hardware. Mastering pointers is essential for anyone aiming to become proficient in C programming or work in fields that require low-level memory management.